we're going to look at another antiderivative problem here. So when you first look at this, you should say, do I know this? Do I know this antiderivative? Is this one of the ones I'm supposed to have memorized? And the answer is no. You should say that pretty fast. I do know the antiderivative of x, or I do know the antiderivative of square root of x. I could rewrite that in terms of power rule, but that's not what I have here. I have a product of functions. I can't just integrate products by integrating the pieces of it. So we might think about what to let u equal to try a u substitution. So typically, we let u equal an inner function as a place to start. That doesn't always work. Sometimes we have to be a little bit more creative with what to let u equal. But here, I have a pretty obvious inner function, 2x plus 3, inside the square root. So that might be a thing to start with for my u substitution. All right, so then the next step, you want to find your du. So 2 dx. And then you need to start matching things up. All right, so in place of the 2x plus 3, I'll put u. I don't have a 2 dx, but I can divide through by 2 to get 1/2 du equals dx. So in place of the dx, I'll put 1/2 du. We have a little bit of a problem with this one, though, in that I have this extra x left over that's not accounted for here with my u and my du. So there are actually a couple different ways to handle this, and there are other examples of problems like this as well. But for this problem, you can be a little bit creative with what you've got over here. There's no special name for this kind of problem that we're working on here, but I sometimes call them a backdoor u substitution, because this is going to work, what I have here, but I actually need to go back to my u substitution and solve that u for x. So you back solve your u substitution for x. So I'm going to go over here to the side and do that. So as long as I'm using correct algebra to do that, so I will take my u substitution, u equals 2x plus 3, and solve for x. So I'm going to subtract 3 and then divide through by 2. Okay, so this doesn't always work, and sometimes this just makes the problem worse than it was to start with, but it should actually work in this case. So this is a little bit harder u substitution, definitely not the first kind of problem you want to try, but by the time you've practiced enough of the basic u substitutions, then you're maybe ready for one like this. All right, so we back solved our u substitution for x, and then I can use that to substitute in for my x that I have here. So I've been kind of marking this up. My circled expression is my u, my underlined expression for dx, and then in place of the x, I'm going to put all of this. So then the question is, does that make anything easier, or does that just make the problem more difficult? So let's go ahead and substitute in and think about if that makes the problem any easier. Okay, so in place of the x, I'll have the u minus 3 all over 2. And in place of the 2x plus 3, I'll have u, that's inside a radical. And then in place of the dx, I'll have 1/2 du. I'm going to put that 1/2 out front. Okay, so marking everything up, keeping track of everything, making sure I don't have anything extra left over. All right, so this is a complicated expression too. But actually, because of the way I've rewritten this, I can use a little bit of algebra to put this in a form of antiderivative that I do know. All right, so I have a 1/2 out front. I can think about this as having a coefficient of 1/2 as well, u minus 3 quantity times 1/2. So I can pull the other 1/2 out front so that I have a coefficient of 1/4, the 1/2 that was already out front times the 1/2 that I get from here. And then I'm going to write that as u minus 3, the quantity, and that will all be times the square root of u, which I can write as u to the 1/2 power. So this is still not an antiderivative, I know, but if I use distributive property to now distribute through, then I'll end up with just a sum of basic antiderivatives that I do know. Okay, so u times u to the 1/2. I can think about that as u to the first times u to the 1/2 is u to the 3/2 minus 3 u to the 1/2. And I'm still have not found an antiderivative yet, so I'm still writing that integral sign and my du here at the end. All right, now this is a sum of antiderivatives that I do know, and so just like differentiation, when you have a sum, you can differentiate term by term. Same with antiderivatives. We had one of those properties of antiderivatives that told us we could do that. So my 1/4 is going to be out front times everything here. And then the antiderivative of u to the 3/2, I will use my power rule. I'll add 1 to that exponent. So I'll have u to the 5/2 over 5/2, or instead of putting that over 5/2, I'm going to write times 2/5 out front. And then the 3 coefficient will come along here, and my antiderivative of u to the 1/2 will be u to the 3/2 over 3/2, or times 2/3. All right, at that point I found all my antiderivatives, so I need my plus c here at the end. All right, and from here it's just a matter of simplifying and back substituting. So I need to put back in for my u what u equals. I'm going to go ahead and simplify the coefficients when I do that. You might notice that these 3's here will cancel, so this coefficient that's left here is 2. I'm going to also go ahead and distribute my 1/4 through as I simplify. Okay, so I'll have 1/4 times 2/5 will be 2/20, or 1/10. And then in place of u equals 2x plus 3 to the 5/2. Right, so that's from simplifying this first term that was times the 1/4. And then minus 1/4 times 2 is 1/2. And then substitute in for the u equals 2x plus 3. And that u is to the 3/2 power. And I need a big old plus c on the end. All right, so that is probably the trickiest kind of u substitution that you will see, where you need to back solve your u for x. And that trick of back solving your u for x doesn't always work. Sometimes you get to this part and your expression ends up a harder integral even than you started with, and you can't find the antiderivative. But kind of as a last resort, when you've tried u substitution and kind of the obvious choices don't work, this is a strategy that you can sometimes use, taking that u, back solving it, and then substituting in. All right, do some homework.